Hi everyone, this is Daniel. I already introduced myself on the first video. Uh, Before I go to my presentation for today, I would like to wish you a happy new year, and I wish the next year will be fruitful for each of you. So let's go to my slide. In my first video, I have discussed about initial specification we need to design 2 kilowatt converter. In today's and in my next consecutive videos, we're going to see how functional design specification document for 2 kilowatt converter can be made will be discussed. Today's video only focuses on how to make block diagram for 2 kilowatt converter. Since converter is an embedded system, before constructing the block diagram for 2 kilowatt converter, we need to look typical embedded system block diagram. Any embedded system have one or more parts from the list stated inside yellow rectangle. Power supply unit. The main purpose of power supply unit is to distribute power to different embedded system units. User interface. The purpose of this unit is to enable user and embedded system to interact. User interface can be LCD, button, keyboard, or LED, or push button or switch. Another unit is the control unit. This unit is the brain of the embedded system. Another unit which can be found in a typical embedded system is the data storage device. This device used to store data in permanent or temporary form. Sensors. Sensors are devices that converts physical stimulus such as heat, light, sound, pressure, temperature, and so on to electrical signal. Connector. Connectors are a junction which enables embedded system to send or receive signal from or to another embedded system. Communication port. This unit enables the embedded system to communicate with another embedded system. Communication port can be CAN, UART, USB, and etc. I designed system block diagram of 2 kilowatt converter as shown in this slide. The system takes 3-phase power through 3-phase header. And after doing necessary manipulation, expels 3-phase power to the motor through header. Another important point in this block diagram is that the system have power supply unit which distributes biasing voltage to different parts of the system. Biasing voltage can be plus 12 volt, plus 5 volt, plus 3.3 volt, and plus 5 volt. Control circuit unit can be in this block diagram can communicate with another system using USB communication port. The system also have voltage and current sensing unit. This unit senses current and voltage at DC, bus, and MOSFET bridge. Digital to analog converter, hysteresis current control circuit block, and multiplexing block is added to perform analog hysteresis control technique. These are the main description about this control system. If we take out only power electronics schematics from previous diagram, it would be as shown in this slide. Let's see each unit one by one. After taking three-phase input from the three-phase power supply, the voltage is rectified by passive rectifier unit. Based on the sensed signal from the voltage and current signal, the control unit will perform computation, and then based on the computation, the control uh, unit decides switching pattern of the MOSFET bridge. Then the manipulated signal will be delivered to three-phase motor. On my next tutorial, I will show you how I designed the schematics, PCB, and 3D view of the PCB. For this episode, that's all I have. Thank you very much.